dear students, you remember last time we introduced the types of variables. We discussed variables and then the implications when you have numbers, identifications of variables. Now, we concentrated so much on the discrete random variable as students of applied math. Now, we want to add on, after you have known those basics, if you can work out the probabilities and those unknowns, we want to add on the properties, the mean and its properties. We are going to add on the mean and its properties. This is what we are going to add on, the mean and its properties. Then we shall also work out the variance and its properties. Now, what you should do, note first note that, one, the mean is the same as average, if you are all aware, is the same as the expectation. Now, in A level, in applied maths, we normally use this commonly, but be aware about this. And two, say, you need to be aware the symbol for the mean is EX, is meaning the mean, which is the average or the expectation. Be aware, the expectation or the average, they are meaning the same. So we normally use this for our symbol. And the formula is that EX is equal to the sum of all X probability of X is equal to X. This is the basic formula for the mean. It is the basic formula for average of a discrete random variable. In the case you think you get mixed up, you say of a discrete random variable. Of a discrete random variable. Because that's what we discussed last time, so be aware. We're just extending. So the mean is given by the formula sum of all X is X and the probability of X is equal to X. That's the mean. Now, what are the properties? As a student of applied mathematics, for this you need to know these properties because we are going to use these properties for our computations as an applied math student. So you need to be aware of the properties of the mean. You need to be aware of the properties of the mean, which we have said is denoted as EX. Now, property number one is that if A is a constant, the expectation of a constant is equal to a constant. Is equal to what? A constant. That's property number one. And for principal math students, you need to be able to prove that expectation of a constant is a constant. You need to be aware and be able to show that the expectation of a constant is a constant. So, what's the proof? We have uploaded some of those, but we have not shown this working because we expect you to attend and be able to be following. And since it's recorded, you'll be able to replay it over and over. So how do we show that the expectation of a constant is equal to a constant? That's the issue. So we want to have that proof. And how do you prove it? The proof is, we begin from saying, from the expectation, from this formula here, from expectation of that being equal to the sum of all X probability of X is equal to X. If A is equal to a constant, that means expectation of a constant, you will substitute where you get X here, you put your A. Because now we're looking for expectation of a constant. So you substitute where you get X, you put your A. So that will be equal to the sum of all of X. When we shall have this X, which is outside the probability, remember the sums of probability is equal to 1, as we discussed last time. So we shall substitute here. So this will be equal to A probability of x is equal to what? X. Now, given that this one is a constant, this one is a constant, so from this part here, since we are summing a's and their respective probability, so we can pull out a constant from our basic algebra. So this will be equal to a, the sum of all of x, probability of x is equal to x. But we discussed last time, we said that the sum of all of x, sum of all of x, probability of x is equal to x is equal to 1. Therefore, our expectation of a constant shall be equal to a times 1. This one here, this one is 1. The sum of all of x is that one. Hence, expectation of a constant is equal to a constant. Have that in your mind. Property 1 of the mean. The expectation of a constant is a constant. So if I have a number like 2, its expectation is 2. If I have a number like 3, its expectation is 3. Even if you have so many 3s in a row, the expectation of that shall be, because a constant number will be 3, expectation of that constant shall be 3. Even if you have 10, expectation of 10, even if you have 100 tens, the average of that one will be equal to 10. So expectation of a constant is a constant. That's property 1. Now, property 2, the second property which you need to be aware, expectation of ax. If, still where a is a constant, if we multiply a and x, its expectation shall be equal to a expectation of x. That means what? If I get a constant and multiply by observations, its expectation shall be that constant times the expectation of that. So how do you prove this? As a student of applied math, you should be able to prove that expectation of ax is equal to a expectation of x. So you still begin and say, from the same beginning, from expectation of x being equal to the sum of all of x, x probability of x is equal to what? X. This will imply that the expectation of ax shall be equal to the sum of all of x. So we shall replace, for this case, we shall replace this one for that one. This one is ax, so when we replace here, this will be the sum of ax, probability of x is equal to x. Now, after doing that, since this one is a constant, our a here is a constant, we can therefore say, we pull out our constant and this will be equal to a sum of all of x. X probability of x is equal to x. But the sum of all of x, x probability of x is equal to x, is equal to expectation. You see? So this part here is an expectation. So you can therefore conclude and say, therefore, expectation of ax shall be equal to a expectation of x as required. If you are required to prove that the expectation of this one is equal to that one. So the beginning point is still that one. Keep that in your mind. The beginning point is the formula, mastery, managing the formula and putting those values. Then we move to the next one. The next one is another property of the mean. And these ones, you must have them at your fingertips. Keep them, keep these proofs as a student of applied math, keep them at your fingertips. You also need to be aware, another one, if our A, if we have two constants, A and B, if A and B are constants, if A and B are what? Are constants. Be aware, as an A-level student, expectation of ax plus b. Expectation, this is also another property of the mean. Expectation of ax plus b shall be equal to Look at this. This A times X, this is a constant. So you'll be having A expectation of X plus B. Or this can be written as B plus A expectation of X. So can you also prove this as a student of applied math? So you still go back to the formula and say proof or showing. Somebody can say show that this one is equal to that one. For higher level students. So you say from all the time from what? From expectation of X being equal to the sum of all of X. X probability of X is equal to what? X. Expectation of AX plus B, if A and B are constants, shall be equal to, so you see this, an expectation, when we take this one inside here, we shall be having E AX plus E B. But don't forget that this is a constant, and this is also a constant. So because of that, therefore, we can pull out these constants out. We shall be having that one plus, and we said earlier on, expectation of a constant is this, the constant, so this is plus B, hence shown, hence shown, or proved. So basically, those are properties of the mean, and we shall be using them. If time allows, we won't use all those properties, but first know that, have that in your mind. Now, I want to combine this with the variance, and that we handle all of them at once. Because the common challenge some students get in A level of applied math is that they may master only this part. After mastering this part, now when we combine with the variance, they get stuck. So it's important for you to understand all these proofs in totality. So these are the basic properties of the mean for a discrete random variable. Now, keep that in your mind. And we are going to apply all of them. Now, we want to also look at the variance and its properties. Then we shall apply all of them at once for easy understanding and application without you getting stuck. So let's look at the variance. The variance of a discrete random variable. This one should become familiar now with you. RV will be for a random variable. Variance of a discrete random variable and its properties. Now, first part is what's the variance. Now, the standard formula for the variance, variability away from the mean, is noted as var x. Some books just write Vx, Vx like this. So if they write like this, be aware. Somebody can write this, or just use these three letters, or just use this. It's given by the formula. Two formula here can be written. One, you can use sum of all of x squared, probability of x is equal to x, minus the sum of all of x probability of x is equal to x. This one, we square this one. This one must be squared. Now, this when you are using the basic principle of sums. Now, this formula can also be written as x squared minus x, this one squared. This one, once you have understood the use of this, then you can keep on using this one. It means the same because this x squared. So since we are dealing with the x squared, so it's an expectation of x squared. Remember, expectation is x and the probability of x. So therefore, x squared, probability of x is equal to x, shall be equal to expectation of x squared, the means of x squared. Then this one will be the expectation of x and their respective probabilities, which will be expectation of x squared. So once you have that as first note, then the question is, what are the properties? What are the properties of the variance? Properties of what? The variance. Just like the mean, you must have this at your fingertips, properties of the variance. Both, you must be aware, you should be able to prove them, you should also be able to apply them as a student of applied math. We are going to, after proving this, we are going to apply them. So, what are these properties of the variance? Now, one, if A is equal to a constant, if A is equal to a constant, the variance, I've said we use that symbol of a constant, shall be equal to 0. The variance of a constant shall be equal to 0. That's property 1. You can list all of them, but it's good we do one by one, then we keep on showing. So can we prove that the variance of a constant is equal to 0? So we begin from basic principles. We begin from here. If you're using the basic, for you to understand well, use this one. Then later you can apply here. After you have understood this one, it becomes very easy for you to just plug them here. Now, what will you say? And it's important for you to understand from this part. Why? It helps you to write this one easily without any big problem. So you say from the variance of A, let's state the formula where it makes up from the variance of x being equal to a sum of all of x squared, probability of x is equal to x, minus the sum of all of x probability of x is equal to x, this one squared. From that formula, if A is a constant, if our A is equal to what? A constant. If our A is equal to a constant, the variance of a constant A shall be equal to, we shall substitute this one here. So we are going to substitute, where we shall get x, we shall substitute that one. So that will be equal to the sum of all of x probabilities. We discussed this last time. I hope you revised them and now you know what it means when we say the sum of all x shall be equal to that probability of x is equal to x. This one remains because we know the sums of probabilities are equal to 1, so there's no need of us substituting here. We are getting the variance of a constant, so we shall substitute this s times their respective probabilities minus the sum of all of x, a probability of x is equal to x. This one is supposed to be what? Squared. Now, if this one is squared, don't forget that this is a constant from our basic algebra. So this will be equal to a squared, sum of all of x, probability of x is equal to x. Now, minus this will be sum of all of x. This one, you can also pull out a and say probability of x is equal to x. This one is supposed to be what? Squared. Since this one is still a constant, we can bring it here. So we shall end up by getting a squared, sum of all of x, probability of x is equal to x, minus, pull this one out here, we shall have that one as a, sum of all of x, probability of x is equal to x. This one is supposed to be squared. After getting that, now you are aware, but this one is equal to 1. So this will be equal to a squared times 1 minus, this one shall also be 1, this one here. So this will be equal to a times also 1. But this one is also squared. Therefore, this will give us a squared times 1 is a squared minus a squared. Because a times 1 is a squared is a squared, which is equal to 0. Hence, proved. We have shown that the variance of a constant is equal to 0. So if somebody asks you to show that the variance of the constant is equal to 0, begin from the formula of the variance, substitute the constant, and work out that one. Now, another property of the variance, which you must be aware as a student of applied math, is that property of the variance of ax, bar of ax is equal to a squared variance of x. That's another property of the variance. As long as or where our a is equal to a constant. As long as A is a constant, the variance of AX is equal to A squared variance of X. So our proof, can we show, is to begin by saying from the variance of X, so this formula must be at your fingertips being equal to the same sum of all of X squared, probability of X is equal to X, minus the sum of all of X, probability of X is equal to X. This one, from the variance being equal, that one, you should be familiar with. By the way, if you study the formula, we are also aware from our theory of statistics that this formula is similar to the one which we did earlier on. That one we shall discuss as we proceed. So the variance of AX shall be equal to the same process. When you get X here, we substitute AX. So that will be equal to the sum of all of X. AX, this part will be squared. Probability of X is equal to X minus the sum of all of X. This is AX, probability of X is equal to X. This one is supposed to be what? Squared. Now, when we square this one, we shall get A squared, X squared. Be aware about that. Those basics of our algebra. So we shall have this one as shall be equal to the sum of all of X. A squared, X squared, probability of X is equal to X, minus. You have here two options. Either pull out the distance square or square. But for simplicity, we are going to first pull out the constant. When we pull out the constant, we shall have A sum of all of X. Probability of X is equal to X. This one is supposed to be what? Squared. Now, same. Pull out the constant here, we shall have this to be equal to A squared. Because a constant squared shall be a constant. Like 10 squared is 100. 3 squared is 9. 5 squared is 25. So the remaining constants. So A squared will be a constant, so pull it out, and we shall have here the sum of all of X squared, probability of X is equal to X. Now, this will be, everything in the brackets will be squared. So we're going to square this, but don't forget that this one is a product. So we shall have this squared and this product squared. So we shall have here as minus A squared. But this one is an expectation. This is an expectation. So we shall have expectation, this one squared. You see? This one here is also the expectation of that one. So ideally, here now, when you pull out our A, we shall have our A squared into the sum of all of X squared. Probability of X is equal to X minus this is the expectation. Or even if you retain it this way, if you cannot retain this, even if you retain that, you'll be having the sum of X, probability of X is equal to X. Now, which is an expectation? This part here is an expectation. This one is squared. You see? So because of that, therefore, you see, when you now observe this, carefully, this one is the variance. You see from there, this one is the variance. Therefore, you can conclude by just using your good eyes, by observation, as I keep on telling you. And some of these, you just look at them by observation and you're able to make conclusions. So, as a student of primary, you can now see and say it's equal to our A squared variance of X. Variance of X. Why? Because this is the variance of X, which we've done from there. Hence, we can conclude and say the variance of AX. As long as, even if you just wrote like this, the V of AX is equal to A squared variance of X. Have that in your mind. Another very important property after you have and you need to master this. Another property is that, which I'm going to show when we begin the applications. You need also to know that if A and B are constants, if A and B are constants, the variance of AX plus B, somebody should be able to guess. But if you're not able to guess, next time you should be able to guess after revising them, should be equal to A squared variance of X. This one there would, because this one is a constant. Now, the question is then, how do you show? The same process. You begin by saying from. Can we prove this? So, our proof, we begin saying from the variance of X, and a random variable X being equal to, for this particular case, I want to use two approaches. After using this one, the sums, I'm not going to use the other one. So, now, from the variance of X being equal to the sum of all of X squared, probability of X is equal to X, minus the sum of all of X probability of X being equal to X. This one what? Squared. We can say the variance of AX plus B, substitute this one in place of X, shall be equal to the sum of all of X. Substitute this there, you will be having AX plus B, and as above B squared. Be careful. Probability of X is equal to X, minus, when you are showing that, you must be very, very careful about those algebraic signs. This will be AX plus B, probability of X is equal to X. When you get X, you substitute that one. This one is supposed to be what? Squared. Now, we are going to expand this and show that actually the B will be there out. That's the beauty of being advanced. That's the beauty of you being in an advanced level. Now, I'm going to expand this. And this we shall also expand that, but let's first handle this one. Be aware, for this one to save time, as a student of applied maths, we're going to use our useful identities. In our O level, we had useful identities. Applied mathematics involves must apply those concepts, and you should have mastered. You can't apply what you have not understood well. So, those ones who are to revise, go back and revise. Our useful identities in O level. We are now going to use our useful identity here. You remember in our O level, we used A plus B, identity squared is equal to A squared plus 2AB plus B squared. That's one of our identities. We also used A minus B squared is equal to A squared minus 2AB plus B squared. Then there was that popular one where everyone loves the difference of two squares being equal to A plus B into A minus B. And most of you are remembering this one. But also, keep this in your mind as a student of advanced level. So I'm not going to use this identity here to expand that one. Now, so if I'm now expanding that using that identity without necessarily wasting a lot of time on that, I'm not going to expand that. So I'll say the variance of AX plus B shall not be equal to, I'm securing more space because I'm going to show all those steps there. So I'm going to expand that one. I'll say it shall be equal to the sum of all of X. This one will give me, that part, it's going to give me A squared, X squared, plus 2 times that one. So 2 times my A, BX, 2 times that one, plus B squared. That will be this expansion here, but multiplied by the probability of X is equal to X. That will be that one. Then also, so minus this part here. this part. We're also going to expand that. But when we're expanding, we first put this value here. First put this probability into that to be on the safe side. So that will be equal to that bracket. We shall have AX probability of X. Let's keep the sum. Let's keep the sum sign there. So shall have that sum of all of X. We shall have AX probability of X is equal to X. That one there. Then plus B probability of X is equal to X. This one is going to be squared. So after getting that, we can choose to plant in this into the probability, all this into these values here. We shall plant all that. We can also choose to plant this all square first, and we shall plant in. So this will give us now what? This will give us the sum of all of X. We shall have A squared, X squared, probability of X is equal to X, plus 2AB X, probability of X is equal to X. Everything in the bracket must be multiplied by that one, plus B squared, probability of X is equal to what? X. When I expand this, I get that one. Now, so minus, now I expand that one. When I expand that one, before first squaring this, I want to pick this into this. So what does this imply exactly? It implies I'm going to square this, but I want to pull out also that one. This is going to be a constant when I put the summation, because I'm going to get a sum of all of X. X, probability of X is equal to X. This part here, this one. I'm going to pull out this A and put there. Then I'm also going to pick that sum and put there and say this will be the sum. I pull out the B, that will be B, sum of all of X. Probability of X is equal to X, this one. But this is supposed to be squared. That's the real implication. After doing that, these are constants, so we are going to pull out the constant. We shall have here A squared, the sum of all of X, X squared, probability of X is equal to X, plus, you see this, these are two constants, so we shall have 2AB, sum of, when you put this inside all of that, sum of all of X, and retaining that, X is equal to what? X. Do not forget that this one here will be equal to 1, but we can retain and say it's also plus B squared, sum of all of X, probability of X is equal to what? X. Now, we are going to expand this. The equation is quite long, but from our basic principles, we shall use still our useful identity, our first useful identity. Or, make the work very simple. We first simplify this. This is going to give us 1, because this is the sum of all probabilities. It gives us what? 1. So ideally, this will give us a sum of all of X. X, probability of X is equal to X, plus B. This one is squared. So after doing that, what happens here? We shall be having our A squared, sum of all of X, X squared, probability of X is equal to X, plus 2AB, sum of all of X, X probability of X is equal to X, this 1, so plus B squared, minus, using our useful identity, it will give us A squared. This will give us A squared. The first term will be squared. So we shall have the sum of all x, probability of x is equal to x, this will be what? Squared. Plus 2 times this and that one. So 2 times our a, 2 times our a or b, the sum of all x, probability of x is equal to x, then plus b squared. That will be that one. So after getting that, that's from the basic principles. After getting that, you open up that bracket. So when you open up that bracket carefully, you see this part here. You see this part here. Open, it could be, let me show all the steps after opening. What are you going to get? You're going to get a squared, sum of all x, squared, probability of x is equal to x, plus 2 times ab, sum of all x, probability of x is equal to x, plus b squared, minus a squared, sum of all x, probability of x is equal to x. This one is also squared, minus 2ab, sum of all x, probability of x is equal to x, plus b squared. Now, when you open this is a minus, so this will also be a minus. So you can see the terms which are going to cancel. You'll find that, let's begin. This one, and that one. This one, when you study it carefully, this one are exactly the same. These ones are not the same, so this one will cancel with that one. Then, this plus b squared and this minus b squared, so this one will cancel with that one. And what are you now left with? You are now left with you can see you're now left with this term, and only this term. I hope you follow that. Therefore, I can only write that now and say that will be equal to, so this value now will be equal to, shall be equal to our a squared, sum of all of x, squared probability of x is equal to x, minus our a squared, this a squared, sum of all of x, probability of x is equal to x. This one is squared. Given that these ones are constant, so you pull out a constant and be left with a squared, sum of all of x, squared, probability of x is equal to x, minus, of course, when you pull out, you have that, minus the sum of all of x, probability of x is equal to x. This one retains its square. So you can see, from here, we can see that now we are left with what? The formula for the variance. This is the formula for the variance. And this will now be equal to a squared, variance of x. Hence, proved. So that's the proof for the variance of ax plus b being equal to a squared variance x. Now, after mastering those proofs, the question then is, where do you apply them? How do you apply them as a student of applied math at advanced level? So, this is how we apply them now. Application. So first step is master the proofs, understand them well. We're using from the basic principles. Or even before we got that, let me show a simple way of proving now this one. After you have understood these basic principles, you can use an alternative this. But you must first understand that for you to the alternative method or alternative proof. For all of them, by the way, if you have understood those basic principles, I want to use an alternative proof for variance of ax plus b being equal to a squared variance of x. you use now the other one. You say using, this is the alternative proof, using var x being equal to ex squared minus ex. Using that one, you can say variance of ax plus b shall be equal to expectation. Once you know now the other one, shall be equal to expectation of ax plus b. This part is going to be squared because we are squaring it. We are going to get that one. Then minus, open brackets, expectation of ax plus b. We are substituting where we get x, we put that one. We get that one, then we square this one. Now, if we are using this, now at the back of your mind, you must be aware what you are doing exactly. We are working for the expectation of this one squared. So, ideally, you combine now the identity here and say this would be an expectation of a squared, x squared plus 2 times a bx plus b squared. Then this would be a expectation of x. Because this is a constant, since you have already understood that the expectation of a constant x is equal to ax. So that will be that. Then the expectation of a constant also will be a b. So you can say plus b. But this time is going to be squared. So once you have done that, at the back of your mind, you know you're dealing with constants and this random variable x. So you can write that and say, I'm not going to make this get into the bracket, but keeping these constants out. So that will imply what? That will imply that I will be having a squared, expectation of x squared. And I will be having plus 2 ab, expectation of x. Then plus expectation of b squared will be b squared, expectation of what? A constant. And this one I'll be having minus what? You also open this using the useful what? Identity and say that will be equal to minus a squared ex, expectation squared, plus 2ab, expectation of x, plus b squared. Don't forget this minus that one. So this will be equal to a squared, expectation of x squared, plus 2ab, expectation of x, plus b squared, minus a squared, expectation of x squared, minus 2ab, expectation of x, minus b squared. So once you have this now, you can now see this term here. This term here is the same as this term. This one is positive, this one is negative, so they will cancel. This one is positive, this one is negative, so they will cancel. And you will be left with a squared, expectation of that squared, minus a squared, expectation of x squared. So technically, you come to the same conclusion. I say this will be a squared, open brackets, a, that squared, minus expectation of x squared. And this is equal to a squared, variance of x. These are now, after you have understood this, immediately you understand this now, you can play with this as a second option. First, understand this. Immediately understand this, you can now use those without. Do not just cram. So similarly, we can also say from the other one. If you want also to show using the same one, you want to show that the variance of ax using that second alternative, variance of ax is equal to a squared variance of x, and you are using the expectation. You say from variance of x being equal to ex squared minus ex b squared. I will now say my variance of x shall be equal to my variance of ax. That one is ax here, shall be equal to expectation of a squared, x squared, minus expectation of ax. This one supposed to be what? Squared. And this will be equal to, pull out this constant, will be having a squared, expectation of x squared, minus A, expectation of x, this is going to be squared. And this will be equal to A squared, expectation of x squared, minus A squared, expectation of x, this one squared. And this will be equal to A squared, pull out that, EX squared, minus expectation of x, this one squared. And this is the same as A squared variance of x. If you have understood the other principles, we can now use those other principles of that. So, after doing that, let's look at the applications. Applications in applied maths, how do we apply all these proofs which we have been doing for the last 40 or so minutes? This, how do you apply them? Now, applications. And understand these applications now carefully, including those proofs very well for math students. Now, if you have example one, given a random variable, such that, or we can even be precise, highly precise, given a continuous random variable. For the beginning, let's first concentrate. Given a discrete random variable, such that if we are given a discrete random such that the probability of x is equal to x, if it is discrete, is equal to kx with 1 for values 1, 2, 3, and 4. Even if I put like this, 0 elsewhere, as we discussed last time, and say somebody says find A, the constant. Then somebody says B, expectation of x. So we want to find the constant. We want to find A, the constant, expectation of x. Then C, somebody asks you 3 times the expectation of x. Another person, he also adds there 3 times variance of x. E, expectation of 3x, or even use another constant, 4x minus 5. F, the variance of 6x. Just scale a bit plus 7. So you start seeing 6 and 7 and say, how will I work out the variance of all that? The question then is, first, if this one is a discrete random variable, what first condition is supposed to be applied here? What's the condition for a discrete random variable, which we discussed last time? That's the first beginning point. What do we know about a discrete random variable? For you to work out that constant, we know that the sum of all of x, probability of x equal to x is equal to 1. So that means what? The probability of x is equal to 1. Because it's take on values, it takes on values 1, 2, 3 up to 4, and 0 elsewhere. That means the probability outside these values is 0. It's not existing. So the probability of x is equal to 1 shall be equal to k times 1, which will give us 1. This will give us k. The probability of x is equal to 2 shall be equal to k times 2, which gives us 2k. The probability of x is equal to 3 shall be equal to k times 3, which gives us 3k. The probability of x is equal to 4 shall be equal to k times 4, which is equal to 4k. Now, since this is true, this implies now that our k plus 2k plus 3k plus 4k is equal to 1. So when you add this gives us 3 plus this 3 plus this one. So that gives us 10k is equal to 1. Therefore, our k is equal to 1 out of what? 10. Now, after getting this, we are now going into application. First of all, what do we know about this? And this is how the question can be framed. You see, this one means expectation. This one means variance. This one is 3 times that one. That. This one, expectation of 4x minus 5. This one, the variance of 6x minus that one. So you need to be abreast with these symbols. So that means we are going to work out the expectation. Which expectation is the same as the mean, the average. See? So, to cut the whole solution for this question, you draw a simple table. You can draw by this table for all these values, but to avoid mix-up, let's draw a table by table. We shall draw a table for this one. We shall draw a table for this one. For this one, we're going to use the property. This one, we shall also use the property at a later time. This one also we shall use the property. So, if you have understood our properties, so we shall come here and say, our table of values, we want to work out now this one here. The expectation. Application of now, our concepts, we shall say, we have already known the probability, so we now have the probability distribution. So, keep this at the back of your mind. Expectation of x is equal to the sum of all of x. X probability of x is equal to x. Keep also this, the variance of x is equal to the sum of all of x. X squared probability of x is equal to x minus the sum of all of x. X probability of x is equal to x. This one is squared. Keep this. This must be at your fingertips. So, if you have this in your mind, that means what? I am going to get the probabilities times their observations, and I will sum them. Now, since I'm going to have that, I'll just draw a table. I'll draw a table of values. Table of what? Values. So, I'm going to have my values. So, observations are these. What are these observations? These will be their respective probabilities. So I will have there 1, its probability is equal to k, and we have just found k here is 1 out of 10. So this is 1 out of 10. If k is this one, so the probability here is 2 out of 10. The probability here is 3 out of 10. So if you did the other question, now here it should be our cover. It's 4 over 10. So you list them with their respective probabilities. Probability of x is equal to x. So for 1, it's 1 out of 10. For 2, it's 2 out of 10. For 3, it's 3 out of 10. For 4, it's 4 out of 10. Now, ideally now, to get the expectation, we shall multiply that. So we shall have our x probability of x is equal to x. That one. So we shall multiply this one by that one, which is 1 out of 10. This one times that one, which is 4 out of 10. This one times this one is 9 out of 10. This time this one is 16 out of 10. So we shall now sum these ones to get the expectation. Because the expectation is a sum, once you have this, is a sum of all x. All those observations, their respective values times with their respective probabilities. So we shall sum this one. I keep on telling you that we don't need to, we need to be observant and maybe tactful. Like now here, we see that this one is a common number here. We don't hurry to simplify this. Even if we had a opportunity to cancel here, don't cancel. I don't cancel in the table. Just now write and say, here expectation of x is equal to the sums of this one. Is equal to the sum of all of x. X probability of x is equal to x, which is equal to 1 out of 10. Of course, at advanced level now you can sum this observation. But if you're not sure, better show all the steps. meaning 1 out of 10 plus 4 out of 10 plus 9 out of 10 plus 16 out of 10. We are summing this since they are the same numbers. So we shall sum this plus this is 5, 14. So you have here 14 plus 16. So that gives you 30. So which gives us what? 30 out of 10. So it's 3. So that means the expectation is 3. And one key issue also for advanced level is that the value you get an expectation for a discrete random variable should be a value within this observation. The expected value, the mean, should be within that. If you find that the expectation is outside, then that means you have made a mistake, either in your computation or you are going to use the right formula. That's one simple check. Now, if we are working out the variance, and the variance is this one, that means what? We are going to get this one squared, then their respective probabilities. The observations with their respective probabilities. So what we need to add on our table, x squared. So our x squared, what are our x squareds here? So those x squared, that will be 1, that will be 4, that will be 9, that will be 16. Times these probabilities. So our x squared times the probability of x is equal to x. So that means what? We shall be multiplying this. If we're using the same table, be careful. Some people might make a mistake and multiply by that one. This one here times that one. So that will be 1 out of 10. This one times that one, which will be 8 out of 10. Don't rush to simplify. I've told you that before. This one times that one is 27 out of 10. Then this one times that one. 16 times 4 is 64 out of 10. Once you're done with that, then you can humbly now come and write and say, that means what? That means the variance of x. The variance of x. If you already know the formula, like the sums of this square. So we are going to sum this one here. So which will be equal to 1 out of 10 plus 8 out of 10 plus 27 out of 10 plus 64 out of 10. Now, with now our scientific calculators, which they allow us to use with the A over B, you can even evoke that in your calculator after you have planted this. Then you plant these figures here into that, and then you get this. So you sum this plus that, you get that one. But minus the expectation. In this question, we have already worked on the expectation because this is an expectation. So our expectation is 3. So minus 3 squared. That will be the variance of that. Then now this one, this part here now. You see this part is already saying a constant times the expectation. So this one's a constant. So our answer for this one. And that's the idea about you understanding the applications of our proofs. Now, here we don't expect to give you a lot of marks at this point now because you now know that you know what it means when you're dealing with the constant with the expectation. So the answer here is just the same as 3 times the expectation is 3, and this is equal to 9. This one is the same as 3 times the variance. So the answer which you get here, if the answer is X, the answer there is Y. So you get that one 3 times Y, the value which you get there. Now, what about now this one here? That's the question. We can generate as many questions as possible from those very concepts. We can say, now, for that B, C, D, E. So for E, our expectation of 4x minus 5. Now, don't forget that this is a constant. This is a constant, this is what? A constant. So, two things can happen here. If you already know what it means, this will be equal to E for expectation of x minus expectation of 5. But this is a constant. So since this one's a constant, the expectation of a constant is a constant. So this will be equal to 4 expectation of x minus 5. So ideally, you now copy. This will be 4 times, what's the expectation of x? The expectation of x is this one here. Application now, applied math now. The expectation of x is that one. So this time 3 minus 5. And this is equal to 12 minus 5. And this is equal to 7. That's the expectation of that one. Let's now come to this one's done. Now let's come to this. If you have mastered those proofs, when you now come to this, when somebody asks you, then from here on, what's the variance of this one here? So the variance of now 6x plus 7. You remember, you need to recall, we said what? We said that the variance of ax plus b is equal to what? Is equal to a squared variance of x. You just say, therefore, but I'm not saying you also tell the examiner, recall. You just say, from this one here, because you must show that you know. You say, from the variance of this one being equal to that one. And you say, the var of 6x plus 7 shall be equal to 6 squared, variance of x. But remember, I called my variance of x to be equal to y. So, if the variance of x is equal to y, so this will be equal to 6 squared times y, and will be the variance of the whole of this one. So that's the application. That's the application of the issue of the variance and the mean. I get another example. Now, in the previous exercise, I said a tetrahedral die is tossed. We said a tetrahedral die is what? Tossed. Now suppose somebody tells you, this time around, a coin is tossed. Now, if we have a coin tossed and our probability distribution, and we call our probability distribution this time we call it probability distribution Z, the number of heads. The number of what? Heads. Now, if this coin is tossed 2 times, this coin is tossed what? 2 times, and somebody says number of what? Heads is our probability distribution. Then somebody says, if it's tossed 2 times, find. Let me do this as our last one. Find the expectation of 2z minus 3. That's our A. Our B, the value of, say, 3z minus 4. Now, in such a situation, you be careful, because first, you told you it's a coin which is tossed 2 times. So if a coin is tossed 2 times, what happens? And they're telling you that the random variable was the number of what? Heads. The number of what? Heads. So you must generate first the coin. When it's tossed 2 times, we shall have our head and our tail. When this coin is tossed 2 times, the first tossing we get a head or a tail. The second tossing we get a head or a tail. A head or a tail. This is the first toss. This is the second toss. That means what? Our sample space shall be equal to our head and a head, our head and a tail, our tail and a head, our tail and a tail. Now, the number of heads, if you did all the other numbers, our Z now is the number of heads. The number of heads can be 0, there may be 1, there may be 2 in the 2 tosses. So you generate a probability distribution from that. Then, after generating a probability distribution, you must now employ this now in your formula. Our probability distribution is the number of what? Heads. So you now ask yourself, what's the probability? What's the probability? The probability that, okay, if you did the other ones, I can now write straight away here. Our Z, and the probability of Z. Use Z, stick to the symbol. If they have instructed you in the question, number of heads, the one called Z, so you stick. Call it Z. So the probability of capital Z is equal to small z, not S, small z shall be equal to, so we write them. So we may have no head, that means they're all tails, and this is a quarter. We may have 1 head, this 1 and 2. one head, one head, one head. So that's 2 out of 4. Then we may have 2 heads, 2 heads, 1 out of 4. So now what do we do from here? So from this question here, must be aware that in A, we are looking for expectation of 2z minus 3, which we know. This is a constant, this is also a constant. So that will be equal to expectation of z minus 3. Are you seeing? So be mindful about that, be aware about that. Those are the properties, being the variance of 3z minus 4 shall be equal to 3 squared variance of z. So that means we need the expectation and we need the variance. So the expectation here, we shall multiply our z. Probability of z is equal to z. So we multiply those ones here. This will be 0, that will be 2 out of 4, that will be 2 out of 4. So you sum this, that will be that. Then we shall also need z squared. Z squared, there will be 0, 1, and 4. And we shall have z squared. Probability of z is equal to z. It will help us to work out the variance. So you work out this one times that one. That will give us here 0. This one times that one. That will give us 4 to 4. This one times that one. That will give us 4 to 4. So you add these ones here. So after you have done that, I hope I'm not too fast on that. So we sum this. So we shall just come and say, therefore, after you worked out that, expectation of 2z minus 3 shall be equal to 2 times expectation of this. The expectation of that one is this sum here. That will be 2 out of 4 plus 2 out of 4 minus 3. Then you add this plus that, and which will give us 2 times 4 over 4 minus 3. And this will give us, take care, 4, 2 minus 3. So that will give us minus 1. That will be that one. Then we come to the last bit now. For the variance now. For the variance of 3z minus 4 of z shall be equal to 3 squared variance of what? Z. And this will be equal to 3 squared. So the question is, what's the variance of z? So you substitute the variance of z, which is equal to expectation of x squared minus expectation of x. You see the variance of that one. So you substitute them in that. The value of that. So this is the expectation of z squared. So you work out this sum here. You add this and substitute. Here minus the expectation, which is that one. But this expectation must be squared. So now, what have we done this afternoon? 1, we have done expectation and its properties. 2, we have done variance and its properties. 3, I've given an example of application of both of them. So once you master that, and now that we have this locked down and you have time, read through these proofs, understand all these proofs very well, and be able to do that exercise which we have forwarded to you. In case you have questions, you forward next time. And if you have J. Crochet and J. Chambers, read it through and do most of these questions. I wish you the very best. We are locked down. And if you have J. Crochet and J. Chambers,